Example 7, finding projectile height. If a projectile is launched from ground level with an initial velocity of 96 feet per second, its height s in feet t seconds after launching is given by the following equation. S is equal to negative 16t squared plus 96t. The question is, when will the projectile be greater than 80 feet above ground level? So greater than 80 feet is what we need to pay close attention to. So for step number 1, we know that S, when is the height, going to be greater than 80 feet? Now, what do we know that S is equal to? Well, S is equal to that, which is negative 16t squared plus 96t, and we want to see where that's greater than 80. Okay, so let's go ahead and then first subtract 80 to both sides of the inequality. So we have negative 16t squared plus 96t minus 80. I want to figure out where is it greater than 0. Okay, so now what we want to do is we want to factor this, but does each term have something in common? Well, they all have a negative 16 in common, which means that we can divide everything by negative 16. Which means we have to divide both sides of the inequality by negative 16. But what's important to remember here is that when you divide by the negative number, we need to flip this inequality. So we get t squared. 96 divided by negative 16 is negative 6, so that's minus 6t. And then negative 80 divided by negative 16 is going to be positive 5, and that's going to be less than 0. So this is the inequality that we're going to be using now when we're testing. Okay? So now that we've done that, now we want to be able to factor. So if you recall, when we factor this, this is going to be 5, and the value of b is negative 6. So what two numbers can we multiply to get positive 5? When we add them together, it's going to give us negative 6. Well, that's going to be negative 1 and negative 5, because negative 1 times negative 5 gives us positive 5. Negative 1 times negative 5 gives us negative 6. So now when we factor this, we're going to get t minus 1 times t minus 5, and that's equal to 0. So that means we have t minus 1 equals 0, or t minus 5 equals 0. So that means t is going to equal 1, or t is equal to 5. So now we found our testing points. So now in step number 2, we're going to draw our number line, and then we're going to use the same procedure we've done with our other examples. So we have 0, we have 1 as a testing point, and we have 5 as a testing point. We're going to draw our lines up and then create our regions. So we have region 1, region 2, and then region 3. Okay? So let's figure out what our intervals are. So we know that we're using the less than symbol, so we have to use parentheses. So it's going towards negative infinity. So the first region has negative infinity to 1. Region number 2 is going to go between 1 and 5. And then region number 3 is going to go from 5 to infinity. So let's go to step number 3. Okay, we're going to find a testing point. So for region number 1, we can pick 0. Now again, we're going to use the easiest of the inequality. So we're going to use the inequality t squared minus 6t plus 5. Set that to be greater than 0. So we have 0 squared minus 6 times 0 plus 5, and that should be a less than symbol. So let me go ahead and rewrite that. It should be less than. And so is 5 less than 0? Well, that is false. So it's false for region number 1. Okay, for region number 2, we can pick a number in between there. So we can pick 2. And again, we're using t squared minus 6t plus 5 and less than 0. So we have 2 squared minus 6 times 2 plus 5. So we have 2 squared, which is 4, minus 12 plus 5. Well, that gives us 9 minus 12, which is negative 3. And negative 3 is less than 0. So we know it's true for region 2. So let's try region 3. We're going to let x equal 6. So we're just going to use the formula here. So we're going to say 6 squared minus 6 times 6 plus 5. And we want to see if that's going to be less than 0. So we have 36 minus 36 plus 5, which is less than 0. So that means 5 is less than 0, which is false. So it is false. So we determined that the solution is going to be true for this region here, which is region 2. And that region is between 1 and 5. So what does that tell us? Well, that tells us the following. That tells us that the interval 1, 5 satisfies the inequality. So the projectile is greater than 80 feet above ground level between 1 and 5 seconds after it is launched.